Today's lesson is on proportions in triangles, and we're going to start right off with the theorem called the side splitter theorem. Your book also calls it the triangle proportionality theorem, but I always call it side splitter theorem. So here goes. If a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. This unit all about proportions. So in other words, if we look at the diagram we have down here, we can see that UT is parallel to this side of the triangle, SQ. And so since we know that QT over TR equals SU over UR. All right, and then we have a converse. It says if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So the converse of the above would be if QT over TR equals SU over UR, then I know that TU is parallel to QS. All right, let me see if they put line symbols. Yeah, I marked these as lines, even though in triangles they're not lines, but we always talk about parallel lines, so that's why I used my line symbols on top. Okay, now there's a corollary to this side splitter theorem, and it says if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if R right here is parallel to S is parallel to T, then I know that UW over WY equals VX over XZ. The segments intercepted are proportional. So we got one more theorem to do, and then we're just going to take off and work practice problems. And this one is the triangle angle bisector theorem. And it says if a ray bisects an angle of a triangle, then it divides the opposite side into two segments whose lengths are, just as you would guess, proportional to the lengths of the other two sides. So in other words, if CD bisects angle ACB, and how do we know that it does here? Oh, because they've got these angles marked as congruent. Then I know that AD over DB equals AC over BC. So those are your four new theorems you got to work with. So let's just take off and do a few practice problems. And as always, I'll do a couple and then I'll let you do some because I don't want to deprive you of all that fun. Okay, so what do we got here? Definitely we're going to use the side splitter theorem, right, to find the length of NR. So I'm just going to label that X. Okay, and what do we know? That since PN is parallel to QR, we know that the sides are divided proportionally. So I know that 9 over X equals 6 over 4. And I could simplify 6 over 4, but this one's pretty easy, so I don't really need to. Just going to cross multiply, get 36. So X is going to be 6 in this case. And, well, we really should relabel it as NR. NR equals 6. Okay. And this one here is the corollary to the side splitter theorem that tells me since those three lines are parallel and they intercept the two transversals, I know that the segments that the sides are divided into are proportional. So 4x over 5x equals 4x plus 8 over 6x minus 10. And definitely, I'm going to simplify this side. I could simplify this side too, and I'm going to go ahead and do that. I'm going to, let's see, I can divide a 2 out of both the top and bottom, so that's what I'm going to do. That'll be 2x plus 4. If I divide a 2 out here, that'll be 3x minus 5. And the reason I'm doing that is because that'll let me make the numbers a little bit smaller. So now what my proportion says is that 4 over 5 equals 2x plus 4 over 3x minus 5. And I could simplify that numerator on the right a little bit more, but I don't think it's going to help things all that much. So we're just going to cross multiply now. And let's see, we'll get 10x plus 20 equals 12x minus 20. Okay, and then let's simplify. I'm going to move my x's to the right, so I'll get 40 over here equals 2x, so x equals 20. And that's all they asked me for. Didn't ask me to find the lengths of those segments, but of course I could. Okay, so this one, is this the corollary to the side splitter theorem? Remember, the three lines have to be parallel. Are they parallel? Yes, they are. How do I know? Oh, because they've got all these corresponding angles marked as congruent. So by the converse of the corresponding angles theorem, postulate, I know that those three lines are parallel. So you pause right here and solve this one and come back. Okay, so there's our proportion. 28 over GH is going to be equal to 30 over 25. So the first thing I did is I simplified 30 25ths down to 6/5. And then the next thing I did is I realized if the 6 were underneath the 28, I could simplify that a little bit more. So I did switch those means. I simplified 28/6 down to 14/3. And at this point, I take the cross product. I get 3 times GH equals 70, and when I solve that, I get 70/3, and we're just going to leave it just like that. No need to turn it into a decimal. Okay, so now I was going to say pause here, but this is the first one we've done using the triangle angle bisector theorem. So I'll do this one with you, and then you can do the next one by yourself. So QPR. So this angle right here is congruent to RPS. That's how we know we've got an angle bisector. So use the given side lengths to find the length of QR. So what did it tell us? It tells us that 12 over 8 is going to be equal to QR, right? QR over RS. What are the lengths of QR and RS? I don't know. I know that whole side is 18, so really all I can do here is I can call one of the sides X, and if I call that one X, what's QR? It's going to be 18 minus X, right? So that's what I'm going to have to use in my proportion. So let me substitute that in. I'm going to have 12 over 8. I'm going to go ahead and simplify 12 over 8. Let's see, 4 goes into 12, 3 halves. So 3 halves equals QR, 18 minus X, over RS, which is X. And now I just take the cross product. So I'll get 3X equals 36 minus 2X. Add that 2X, 5X equals 36. Therefore, X is going to be 36/5. X, that's RS. Okay, that's RS. Unfortunately, they asked us for QR. If I'd thought about that a little bit, I would have labeled QRX. You know, but now, what have I got to do to get QR? I know that QR is 18 minus X. So that is 18 minus 36/5. I know you don't like this one. I got to change that 18 to fifths. So let's see, that's going to be 90/5. 90/5 minus 36/5. So finally, QR is going to come out to be, what's that, 54/5? I don't believe we can simplify that either. So that's that. Okay, this next one, not quite so bad. So you pause here and do it and come back and check it. Okay, there you go. That one was a lot more simple. The only thing we had to remember is to label this segment here as 21 minus x, and then set up our proportion. I simplified 16/12 down to 4/3, cross multiplied, ended up with x equals 12. All right, this one here, we got another case of the side splitter theorem. So we're just going to go ahead and say that 12 over 7x equals 2x plus 2 over 5x minus 1. Okay, I'm going to switch a few things around here. I'm going to switch my means, and at the same time, so I'm going to bring this down here, bring the 7x up here. At the same time, I'm going to factor this 2 out, because that's going to help me simplify this. That'll be 2 times x plus 1, and then I'm going to have 7x over 5x minus 1. Okay? So 2 will go into the 12/6. Now there's really nothing else I can simplify, so I've got to cross multiply here. So I'm going to have 7x times x plus 1 equals 6 times 5x minus 1. Okay, let's just simplify this a little bit more. 7x squared plus 7x equals 30x minus 6. Oh boy, we got a quadratic, so I'm thinking we're going to have to factor this thing. So let's get everything on the left and have it equal to 0. 7x squared. 7x minus 30x would be minus 23x. That would be plus 6, and that's going to equal 0. So, this does not look like it's going to be any fun to factor. I'm going to show you what I'm going to do. Okay, since 7 is prime, I know that one of these has to be 7x and the other one has to be 1x, right? So now I just got to look for these factors of positive 6 and put them in the right place, either here and here. And I know the signs are going to be the opposite of each other because of the negative sign here. So I got to figure out where the 2 and 3 go. Actually, no, the signs are going to both be negative since this is positive. My bad. The sign, well, that makes it easier. Signs are both going to be negative. So now I just got to figure out where to put the factors of 6. And it could be 1 and 6. It could be 2 and 3. So this was kind of tough. So I'm just going to go ahead and tell you the way it comes out. It comes out like that when you factor it. And then I got to set both of these equal to 0, right? So I can solve, or x minus 3 equals 0. So that one's easy. X equals 3. This one's going to give me 7x equals 2. Therefore, x equals 2/7. So there are my two solutions. And that's a tough one. Guys, remind me in class next time. I want to show you a method that you can use to factor a quadratic whenever this leading coefficient is not 1, so that you don't have to just guess and check like I did there. Remind me to show you that method of factoring. And that'll be all for today.